Hi, this is K.Hari Babu, working as Associate Professor in EC Department of MLR Institute of Technology. Today we are discussing about different types of distribution and density functions. First of all, what are the different types of distribution density functions? Generally, we are using uniform distribution function and exponential distribution density function and Rayleigh distribution density function, Gaussian distribution density function, binomial distribution density function and Poisson distribution density function. Now we need to discuss about uniform distribution and density function. So here, if X is uniformly distributed random variable from A to B, then I want to find uniform density function, that is fx of x, that is 1 by upper limit b minus lower limit a in the range of a less than x less than b, 0 otherwise. That is, this is my random variable is varying between minus infinity to plus infinity. So here this is 0. Here a to b, from a to b my random variable is uniformly distributed. So now I need to find density function fx of x equal to 1 by b minus a. This is my density function. Now I need to find distribution function also. How to find the distribution function? Already we know the relation between distribution and density function, that is distribution function fx of x is equal to integral of x equal to minus infinity to x small fx of x dx. This is the relation between distribution and density function. I know already density function, that is 1 by b minus a in the limit of a to b. So now I need to write distribution function fx of x is equal to integral of, my lower limit is x, that is x equal to a, and I need to find the function up to x value, that is integral of x equal to a to x. My density function is 1 by b minus a with dx, that is fx of x is equal to, here 1 by b minus a is constant, that's why 1 by b minus a into integral of x equal to a to x 1 with dx. I need to find the integration for 1. So that is the constant. So simply we can write 1 by b minus a. Here 1 means integration of 1 is x from x equal to a to x. So 1 by b minus a into x minus a. Now I need to write the limits for this distribution function, that is distribution function capital fx of x is equal to, for example, if x is less than or equal to a, what will happen? If x equal to a means I can write a minus a by b minus a. A minus a means 0, na? That's why x is less than or equal to a, my distribution function is 0. Next, if my random variable is varying between a to b, so my function is x minus a by b minus a. Next, if my random variable is greater than or equal to b, either b or more than b value, means what will happen? B minus a by b minus a, that is distribution function is 1 only. So that is fx of x equal to x minus a by b minus a for a to b. And my density function is 1 by b minus a. I want to draw the graph for this one, means this is my random variable x. Here it is starting from a onwards, a, and it will be reaches to maximum value at b. From b onwards my voltage is 1 only. This is my probability distribution function for uniformly distributed random variable. So now we need to discuss about what are the applications of this uniform distribution and density function. Generally, mainly this will be used for round-off process. So round-off process purpose we are using this one. And next one, in digital communications, the errors will be rounded to the nearest discrete values. That is, the PDF errors will be represented in terms of uniform distribution and density function only. So this is the total information about uniform distribution and density function. So now we are moving to the exponential distribution and density function. So here exponential distribution density function means here also my random variable x is exponentially distributed random variable and my random variable x is continuous random variable only. Now I want to find or I want to write exponential density function, that is fx of x is equal to 1 by b into e power minus of x minus a by b for x greater than a. If x is less than a means what will happen? That value is 0. So here a comma b will be taken as constant values only. So here and b must be greater than 0. So this is the information about the density function, that is exponentially density function. See here fx of x equal to 1 by b is the constant now, e power minus, that is exponentially decaying function. If we want to draw the graph means this is my random variable is varying between minus infinity to plus infinity. For example, if x equal to a means what will happen? So that is e power 0, that is 1, that is 1 by b. So here at x equal to a, my voltage is 1 by b. Next, if you are increasing means it is automatically exponentially reducing. So this is the exponential density function graph. By using this one, I need to find probability distribution function. Already we know the relation between distribution and density function, that is fx of x is equal to integral of x equal to minus infinity to x small fx of x with dx. So here fx of x is equal to integral of x equal to, my lower limit will be taken as a and my upper limit will be taken as x, that is fx of x means 1 by b into e power minus of x minus a by b with dx. I need to find the integration for this one. So we can get, that is fx of x is equal to 1 by 1 minus e power minus of x minus a by b for x is greater than a. If you want to write the limits of this one also, we can write, that is fx of x is equal to, for example, if x is less than or equal to a, what will happen? If x will be less than or equal to a means assume x equal to a. So 1 minus e power minus of a minus a, e power 0. So that is e power 0 means 1. Then 1 minus 1 is 0. That is density function is 0 for x is less than or equal to a. If x is greater than a means we know already general function, that is 1 minus e power minus of x minus a by b. And if x will be taken as infinity, if x equal to infinity means 1 minus e power minus infinity. E power minus infinity means 0. So here my function value is 1. So this is the total information about probability distribution function of exponential. If you want to draw the graph means here at x equal to a onwards, my voltage will be increasing up to 1. So this is the probability distribution function for exponential. Next, what are the applications of exponential function? Generally, it will be used fluctuation of signal strength received by the certain type of radar receivers, and we need to measure the rainstorm measurements purpose, raindrop sizes measurement purpose. We are using this type of exponential distribution and density function. Next, we are moving to the Rayleigh distribution and density function. So here also my random variable x is continuous random variable only. So the Rayleigh distribution function and density function means, first of all I need to write the density function, that is fx of x is equal to 2 into x minus a by b into e power minus of x minus a whole square by b for x greater than a, 0 for x less than a. This is my density function for Rayleigh. By using this one, I want to find distribution function also. We know already relation, that is probability distribution function fx of x is equal to integral of, my lower limit is a and upper limit will be taken as x only. Why? Because I need to find the function up to x, that is fx of x equal to integral of x equal to a to x. My density function is 2 into x minus a by b into e power minus of x minus a whole square by b with dx. So here I need to find the integration for this one, means x minus a whole square by b must be used another variable y. So we can get, that is fx of x is equal to integral of x equal to a to x 2 into x minus a by b into, that is b by 2 into x minus a into e power minus y with dy. Cancel. So you can get fx of x is equal to 1 minus e power minus of x minus a whole square by b. This is my distribution function. If you want to write in terms of the limits, means that is capital fx of x is equal to, if x will be taken as less than or equal to a, what will happen? A means e power minus of a minus a whole square, e power 0, 1, 1 minus 1, 0. If my function is greater than a, that is 1 minus e power minus of x minus a whole square by b, and if x will be taken as infinity, means my answer is 1. This is my probability distribution function for Rayleigh. So applications, what are the applications for this one? So mainly this will be used for white Gaussian noise, that is white Gaussian noise is passed through the band pass filter. At that case we are using this type of Rayleigh function, and this Rayleigh density distribution function is also similar to the Gaussian probability distribution density function. So these are the applications for Rayleigh distribution and density function. Next we are moving to the Gaussian distribution and density function. So here also x is my continuous random variable only. Now I want to write probability density function fx of x is equal to 1 by square root of 2 pi sigma x square into e power minus of x minus mu x whole square by 2 sigma x square for all x values. So here what is meant by mu x, what is meant by sigma x? See here, mu x is mean value and sigma x is standard deviation. Here the probability density function fx of x, that is Gaussian probability density function, is also called as normalized probability density function. So what is meant by Gaussian random variable? Gaussian random variable means if any random variable will satisfy the Gaussian density function, then that type of random variable is called Gaussian random variable. So now we need to discuss about the Gaussian density function. Now already this is the Gaussian density function. Now we need to discuss about Gaussian distribution function. So Gaussian distribution function means I need to apply the integration for this one, that is capital fx of x is equal to integral of x equal to minus infinity to x, that is 1 by square root of 2 pi sigma x square into e power minus of x minus mu x whole square by 2 sigma x square with dx for all x values. See here, this is my Gaussian probability distribution function. Generally, the Gaussian distribution function is also called as normalized distribution function when, that is, sigma x is equal to 1 and mu x equal to 0. In that case, my distribution function is also called as normalized distribution function. That is, f of x is equal to 1 by root 2 pi into integral of x equal to minus infinity to x e power minus x square by 2 with the dx. This is my normalized Gaussian distribution function. Now, I need to provide the relation between those two. That is, I know already Gaussian probability distribution function and normalized distribution function. See here, capital Fx of x means what we are writing, Fx of x is equal to 1 by square root of 2 pi sigma x square into integral of x equal to minus infinity to x e power minus of x minus mu x whole square by 2 sigma x square with dx. And normalized distribution function means Fx of x is equal to 1 by root 2 pi into integral of x equal to minus infinity to x e power minus x square by 2 with dx. So here x minus mu x by sigma x. See here, x minus mu x by sigma x equal to, I am assuming u. So I want to provide the relation between these two means, that is Fx of x is equal to f of x minus mu x by sigma x. This is the relation between normalized distribution function and Gaussian distribution function. See here, I got, that is f of u. This will be taken as u means I know already f of u, or assume u will be taken as x means I know f of x. How to find this f of x? If you want to find this f of x means we need to know the approximation function, that is q of x function. That is q of x is equal to 1 by 0.661 into x plus 0.339 into square root of x square plus 5.51 into e power minus of x square by 2 by root 2 pi for x greater than or equal to 0. So now I know the q of x by using this function. How to find f of x? So here f of x means 1 minus q of x. By using this one I can find the normalized distribution function. So this is the Gaussian. So what are the applications of this one? Mainly this Gaussian distribution and density function will be used for electronics and communication. Generally the signal is passing through the channel may generate some amount of noise either internally or externally. So in that case I want to reduce the noise. Why? Because I want to transmit my voice signal through the channel means I need to reduce my noise signal. So here if you want to reduce the noise signal means here it is approximately equal to the Gaussian function. That's why if you know the behavior of this Gaussian density function or distribution function, by using this one I can suppress the noise, then only my voice signal is passing through the channel. So mainly used for this one purpose only. So now binomial distribution density function. So here random variable x is always discrete random variable only. Here consider one experiment contains two independent events. Here that is 1 or 0, yes or no, true or false, like that. Here if the experiment is repeating n times and here event A is occurring will be taken as P of A equal to P, then the binomial function, otherwise Bernoulli function, that is probability of event A occurs exactly k times is equal to nck p power k into 1 minus p whole power n minus k. So here what is meant by nck? Nck is coefficient, that is n factorial by k factorial into n minus k factorial. See here in this case by using from the Bernoulli we are starting that binomial. Here if n value k value is there na, if n is very large k is very large means I can't find this n factorial or k factorial because it is difficult to find that n factorial. That's why we are moving to the another rule, that is de Moivre Laplace approximation. By using Stirling formula we can write n factorial is approximately equal to 2 pi n whole power 1 by 2 into n by e whole power n. So this is the finding n factorial for large number. This is called as Stirling formula. Here n is very large, K is very large and N minus K also very large. In that case, I can't use this type of formula. That's why I'm using de Moivre Laplace approximation. That is, the probability of event A occurs exactly K times is equal to 1 by square root of 2 pi NP into 1 minus P into e power minus of K minus NP whole square by 2 NP into 1 minus P. So this is the de Moivre's Laplace approximation to finding the event A occurs exactly K times. So next one, we need to move to the binomial. So means binomial means it is also same as, now I need to represent in terms of distribution and density function. That is fx of x, that also equal to summation of I equal to 1 to n nck into p power k into 1 minus p whole power n minus k into del of x minus k. So this is my distribution density function. Now I need to find distribution function. Fx of x is equal to summation of I equal to or k equal to 1 to n nck p power k into 1 minus p whole power n minus k into u of x minus k. So this is my binomial function. So what are the application for binomial? Generally, binomial is used for gaming purpose, and this will be used for radar and sonar purpose. These two are the general application for binomial. Now, we are moving to the Poisson probability distribution and density function. In this case also, here what you are telling in the previous, that is de Moivre's Laplace approximation, if n is very large, k is very large and n minus k is very large means we are using de Moivre's Laplace approximation. For example, in this case also, if n is very large and p, the probability of the event is very small, in that case, the de Moivre's Laplace approximation is not valid. That's why we are moving to the another rule, that is Poisson approximation principle. That is, the probability of event A occurs exactly k times is equal to e power minus np into np power k by k factorial. So this is the probability of event A occurs exactly k times. So now I need to define about the probability, that is Poisson probability distribution function and density function. That is fx of x is equal to summation of k equal to 0 to n, that is e power minus np into np power k by k factorial into del of x minus k. This is my Poisson probability density function. Now, by using this one, I can define the probability distribution function, that is capital Fx of x is equal to summation of k equal to 0 to n e power minus np into np power k by k factorial into del of u of x minus k. So this is my probability distribution function. Now, what are the applications of this probability distribution and density function? Generally, the number of telephone calls are made from particular time period, and how many number of defective elements are there, or how many number of electrons are moving from cathode to anode in particular time period. Otherwise, how many number of vehicles are occurring at the fuel station at particular time period. So mainly this type of Poisson will be used for counting purpose only. So that is the Poisson probability distribution and density function. Yeah, thank you.